You know those perfect bouquets you see at the supermarket? They look so fresh, so natural, right? Well, it turns out that behind every single one of those perfect petals is a world of incredible, mind-blowing science. Today, we're going to pull back the curtain on how these flowers are really made. Just take a look at this. Now, you might think you're looking at an endless field of flowers, but what you're actually seeing is a high-tech factory. It's a production line. But instead of making cars, it's making life. Every single element here, from the air the plants breathe to the soil they're in, is managed with unbelievable scientific precision. So, have you ever stopped to wonder what it really takes to do that? To grow a perfect flower, not just one, but millions of them, all at the same time. Well, it's a journey that involves microscopic warfare, crazy temperature tricks, and an environment controlled down to the last degree. Let's start at the very beginning. Even before a seed is planted.
You see, to grow a perfect plant, you can't just start with any old dirt. You have to build the perfect foundation. It's kind of like building a house, right? You need a clean, stable base before you do anything else. And for a flower, that means engineering the ideal growing medium from the ground up.
And the very first step is something called soil pasteurization. Think of it like creating a totally sterile, super safe nursery for a newborn plant. Before a single cutting goes in, the soil gets treated to wipe out any bad guys, any pathogens or pests that could possibly harm those delicate new roots.
Now, the precision here is absolutely critical. The soil is heated to exactly 70 degrees Celsius and held there for a solid 30 minutes. If you go any hotter, you'll kill off the good bacteria that the plant needs. But if you go any cooler, the dangerous germs survive. It's this incredible scientific balancing act.
Okay, so once the soil is squeaky clean, it has to be perfectly balanced. For a lot of these greenhouse crops, the magic number is a pH of 5.5. Why? Because that specific level of acidity is basically the key that unlocks the pantry, letting the plant's roots absorb all the nutrients they need to get big and strong.
So, the foundation is set. The next big challenge is defense. I mean, think about it. In a greenhouse with millions of plants, a single pest outbreak could be an absolute disaster. But instead of just blasting everything with harsh chemicals, growers are now fighting this really sophisticated microscopic war using biology as their weapon.
So meet one of the main villains, the black vine weevil. The adult bug might nibble on some leaves, sure, but the real damage, the devastating stuff, is happening underground, where you can't even see it. Its larvae just feast on the plant's roots, basically cutting off its life support and killing it from the bottom up.
So how on earth do you fight an invisible enemy like that? Well, you hire a microscopic army. It's so cool. Growers release millions of these things called beneficial nematodes into the soil. These tiny little worms are natural predators that actively hunt down and kill the weevil larvae, protecting the plant's roots from the inside out. And of course, the bad guys don't stop there. Another huge problem is the whitefly. These little insects are a serious double threat. First, they suck the vital juices right out of the leaves, which weakens the plant. And second, they can carry devastating plant viruses, spreading disease from one plant to the next like wildfire. To fight the whiteflies, the solution is, again, something straight out of a biology textbook. Growers release these tiny little parasitic wasps. What they do is hunt down whitefly larvae and lay their eggs inside of them. The wasp larva then hatches and, well, it eats the whitefly from the inside, turning it into this little black mummified shell. It's kind of grim, I know, but it is incredibly effective. This whole strategy has a name. It's called Integrated Pest Management, or IPM. And the goal isn't just to nuke everything with chemicals. It's about playing the long game, being smarter. It's about using good bugs to fight bad bugs, keeping things clean, and just creating a healthy ecosystem to prevent problems before they start. All right, now let's talk about the greenhouse itself, because a modern greenhouse isn't just a roof to keep the rain out. Oh no, it is a full-on, sophisticated life support system. It gives growers total control over every aspect of a plant's reality, from the light it sees to the very air it breathes. And one of the most clever tools in their toolbox is a concept called diff. It's really simple. It's just the difference between the daytime temperature and the nighttime temperature. But by playing with this simple difference, growers can literally sculpt the height of a plant without ever touching it. Here's how it works. If you make the days warmer than the nights, that's a positive diff, the plant stems stretch out and you get a taller plant. But if you flip that, if you make the days cooler and the nights warmer, a negative diff, you actually get a shorter, more compact plant. It's this amazing non-chemical way to get every plant to be the perfect size for the store.
And that control goes all the way to the air itself. To really push growth to the max, growers will often pump carbon dioxide into the greenhouse, raising the levels to around 1,000 parts per million. This just supercharges photosynthesis, letting the plants grow way faster and stronger than they ever could out in a normal field.
Okay, so we've got perfect soil, we've got a pest-free environment, and we have a custom-built climate. The very last stage is all about the finishing touches, the final steps to engineer that perfect, uniform bloom that's going to end up on your kitchen table.
Plants, just like us, need a really balanced diet, and they get it through a process called fertigation. It's exactly what it sounds like: fertilizer plus irrigation. Every single drop of water these plants get is infused with a perfectly mixed nutrient cocktail. It's like getting a complete, balanced meal delivered constantly, 24/7. And for that final, perfect shape, growers often use something called plant growth regulators, or PGRs. These basically act like a brake pedal for the plant. They block a natural hormone that tells the stems to get longer and taller. By hitting the brakes on that hormone, you get a plant that's not just shorter and more compact, but also stronger and sturdier.
So just think about that whole journey for a second. A flower starts its life in perfectly clean, scientifically balanced soil. It survives a microscopic war fought by an army of good bugs. Its exact shape is sculpted by clever temperature tricks. It's fed a custom diet with every single drop of water. And finally, it's chemically tailored for that perfect look.
It really is an astonishing mix of biology, chemistry, and pure engineering. So the next time you see a bouquet of flowers, maybe you won't just see pretty petals. Maybe you'll see a true masterpiece of science. Thanks for joining me.